So today's session, we are looking at software testing. This is the domain 8 of the software development security of the ISC Square common body knowledge. We are going to just scrape the surface. We are not going to go detail like you've seen all of my other sessions. This is my first time doing it, so I'm trying to stay as high level as possible just to initiate discussion and so on. So today's format would be we'll talk about software testing, define it. I have a Wikipedia definition, so we'll just read through that so we all know what we are looking at. We'll also define some of the key terms that I found useful when I was studying for my CISSP. So we'll define those terms really quick, try to cover that in about 5 minutes. And of course, there will be plenty of quizzes or questions in between these slides, so look forward to those. And then we'll get into the methods and types of testing. Now, there are numerous of those. Like if you search for software testing types, you will find at least 100 of those. I mean, depending on who's defining it, they may come up with their own name for some sort of testing, but we are going to look at some of the most common ones that are really for your CISSP exam that you should be aware of. Of course, we may miss a few. Again, if you think of something that I've not covered here and you feel is important, just let me know, and then we can look up the definition for that. Of course, I have the quiz in the end. So let's see what software testing is, and everybody's familiar with software testing and why it is important. So just to give a quick introduction on what software testing is. So it is so important that if you are not going through software testing and not weeding out any of the bugs in the software, it could take human lives. And this was evident with the one of the biggest airline companies that had thousands of airlines flying, had been supposedly software tested, had been certified, and had software bugs that actually resulted in airplanes crashing. And so, why is software testing really important? Yes, of course, it is important for the applications that we use every day are Microsoft Office suites, Microsoft Teams, Google, anything that we do with our phones. But it's also important because it affects or it could affect human life, and that is, I think, regardless of how you look at it, you have to take it seriously. And the organizations that don't end up in jail, end up being investigated. So software testing is an investigation conducted to provide stakeholders with information about the quality of the software product and service that is under test. So software testing is basically anything that you do when you start reviewing your code to when you are have a complete software built and you test and find more bugs and try to fix it, to when you have deployed it in your customers and installed and running, and when you do investigation on the software, check for any bugs, any vulnerabilities. Software testing continues. So software testing happens in all the phases of the SDLC. There is a concept called early testing, which I'll talk a little bit later. But the in SDLC, we will come across software testing in many different phases, like I said. And I have a slide here which will kind of give you a good idea on where these testings occur. It certainly starts after the coding has started. And as I said, the early testing that is defined in the early stages of your SDLC process. And this is done in order to achieve more efficient, cost effective, and high quality software. We already discussed how it's cost effective in my previous session, because if you're able to find a bug and fix it at an early stage, you are actually saving a lot of resources and any kind of damage that the software could have uh, done. And so let's move on to this next slide. Here you can see on the y-axis, the vertical line is the completeness of the software. And on my x-axis, I have the timeline. So as the time progresses, my software is getting developed. And this slide will kind of give you an idea that, regardless of what phase you are in, you have to do unit testing, which is when you have a software that's divided into different modules, and each modules are not integrated yet, but then you have to do some testing on those individual modules before you start integrating, and that is called as unit testing. And then we go into the integration testing, where integration testing is a level of software testing where individual units, components are combined and tested as a group. The purpose of this level of testing is to explore or expose faults in interaction between these different units. So once you have your software tested, the integrated software tested, then you go into the actual system testing. So the system testing is a level of software testing where a complete and integrated software is tested. The purpose of this test is to evaluate the system's compliance with the specified requirements. This is more on the lines of quality assurance, and so you can think about it as a quality assurance test. Then comes the user acceptance testing. Now, your software has been deployed, and the user has to get convinced that this software is what he or she asked for. And so this is where the user acceptance test comes into picture. So the acceptance testing is a level of software testing where a system is tested for acceptability. The purpose of this test is to evaluate the system's compliance with the business requirements, not the system requirements. This is more on the business requirements, and assess whether it is acceptable for delivery. So now we will define these different tests in detail, but I just wanted you to have this timeline so you really understand where the testing happens, right? Testing is happening in the early stages of SDLC. As early as you can start, the better. Did anybody have a question? All right. So there are a few things I thought would be really necessary for us to understand. And I call these just testing terms. I'm sure other people call it different things, but functional and non-functional requirements. I should have said requirements there because we are now looking at functional and non-functional requirements and not testing. So sorry about that. So functional requirements. So what are functional requirements? Functional requirements define the basic system behavior. Essentially, they are what the system does or must not do. And we can think about in terms of how the system responds to the user's inputs as something that is like functional. Examples would be the user requirements, right? So if I want to do design a banking app, then I want to look at the requirements that the user will be able to see his bank balance, will be able to transfer accounts between different accounts, whether it's internal or external banks, to be able to do a few other housekeeping things on the app or the application. And of course, the features. There may be features that come with the application that the end user will be able to use. So those are all considered functional. Without the functional requirements, you will not be able to develop a software. And without the functional requirements, you won't be able to test the software. And without providing the functional requirements, you won't be able to deliver the software as finished. What are non-functional requirements? So non-functional requirements are just the opposite, right? So non-functional requirements specify how the system should perform, or these are non-functional requirements that do not affect the basic functionality of the system. Hence the name non-functional. Even if the non-functional requirements are not met, the system will still perform its basic purpose. So keep that in mind for CISSP. Example would be user experience, how the user feels. Oh, it's so easy to use, the Windows switch real easy, smooth. All of this can be considered as non-functional. Of course, security is also non-functional, while some may argue with that sentence there, but security comes as a non-functional requirement as well, because you can make a system as secure as possible, but it does not really have to be very secure. Um, in order for the app to work, however, in order for the app to be secure, yes, you have to make it secure. So think about it as functional and non-functional requirements. Another important topic or term is SRS, which is Software Requirements Specification. So you need to at least know the definition of what SRS stands for. And I know some people also call it stakeholder requirements. Um, let's see, stakeholder requirements specification, SRS. So what is SRS? Oh, sorry, that was a question. Okay, what is SRS? So a software requirement specification is a description of software system to be developed. It is modeled after business requirement specification, also known as stakeholder requirement specification. So it is like very high level requirements documentation. It's basically a document. Okay, it describes what the software will do. It also describes how well it will perform or how it will perform. It will also talk about some functionality and the needs that needs to be fulfilled in order for stakeholders to be convinced that the software is ready for their consumption. All right, so that was the SRS. So I want to just take a quick break here. I know I have not defined RTM, which is Requirement Traceability Matrix, yet, but I thought I'll just throw this question out because I have seen some of these questions which talk about a term and then it'll basically define it in the answer. So if you have not been able to understand what this question was all about, the next slide is for you. So RTM, which is Requirement Traceability Matrix, is also sometimes called as Traceability Matrix, just TM, or it also referred to as RTM, can be used to map customers' requirements to software testing plan. It traces the requirements and ensures that they are being tested and followed. So this is like a log, but also a list of all the requirements that you have, and you're mapping those to the testing that you're doing, and also providing a method to go back to the requirement to make sure you have fulfilled the requirement. So the traceability matrix is typically a worksheet that contains the requirements with all its possible test scenarios. I say all, but in reality you cannot test everything. Let's say majority of all the testing scenarios and cases and their current state. What is the current state? So if they have passed, if they have failed, if they are under test or being tested. So all of this information is in the RTM. So it's a very useful document. This would help the testing team to understand the level of testing activities done for the specific product. And it could be done for just unit testing or integration testing or the whole system testing, but this is just a document. So think about it like a Excel spreadsheet with columns, and it's a busy sheet of all the requirements. Next term that I think you want to, so I just put traceability matrix because it's the same as the RTM. So the next important concept, and I've seen a question on this somewhere, not necessarily on the CISSP exam, but I've seen, by the way, if you noticed, I had Thor Teaches logo on my thing, and that's because I used those questions from his website. Of course, it's all free. You can go to his website and answer these quizzes, but it is coming from there. So I just wanted to let you guys know. In case you're wondering where I got these nice questions from. So test coverage analysis. Now, what is test coverage analysis? I'm going to define it, but remember it's a percentage, basically saying, how much you finished versus how much you have left. So it kind of gives you the coverage. So what is test coverage analysis? So it is a technique to ensure that your tests are being tested, and your testers are testing your code. I know it's a tongue twister there, or how much of your code you exercised by running the test. So if you have, I have an example after this. Okay, so next slide. So that will give you some really good idea. So let's actually take a look at that. So if the total lines of code in a system component, so when I say system component, it could be a unit, or it could be a module, or it could be a full program. But the total lines of code, let's say, is 1,000, and the number of lines being actually executed through all existing test cases is 650. So as you know, there are always codes in the program that do not run, and the reason why they don't run is either that scenario hasn't taken place, and so you can kind of use that and say, if I haven't tested all of the lines of the code, that means I have not come across all of my scenarios. Now, how will you keep track of this? This is what you'll use, the test coverage analysis. While it is one of the important things, it's not the only important thing. That this is part of your testing uh, metrics. So you have 1,000 lines of code, but all of the tests that you've conducted have only utilized 650 lines. Then if I ask you what is your test coverage, then you'll use this formula. Test coverage equals number of use cases tested versus the total number of used cases. So in this case, the use cases that we tested would be 650, because 650 lines of code was tested out of the 1,000. So it's a very simple formula, but something to keep in mind. All right, question time. So as you may have noticed, I'm giving you a question on something that we have not discussed yet, but it's also a hint as to what is coming next. All right, so this question is, in software testing, a black box test would have how much information?
A, just the software. Yeah, A, just the software.
That is correct. So that is black box testing. So, but we'll look at all the different types of testing here real quick. We have testing methods. Okay, so this is not the only exhaustive list of methods. So if you see something missing here, obviously I couldn't cover those, but I'm going to cover these because I've seen this being used in questions, on all of our practice tests, whether it's a OSG, official study guide, or also in the official practice tests. So I've seen these pop up. Black box testing, as you may know, you already answered that question. So internal system design is not known or considered in this type of testing. Tests are based on requirements and functionality, and inputs and outputs are observed, nothing else, because you don't know what's actually inside that box, which is the code. In white box testing, the internal design or the internal system design is considered for this type of testing. Tests are based on knowledge about the internal logic or an application code. So while I'm talking about all this, also try to think who would be doing these tests. Okay, so a black box test, would that be done by a programmer? Probably not, because programmer knows what's going inside the code or what's inside the program. However, a third party testing company who you give this application to, they will not know what's inside it, and so they would be doing black box testing. It's very important because in the exam they will ask you in a very indirect manner as to who would be doing the black box testing or white box testing. So the white box testing on the other hand would be someone who knows the code, not necessarily, because you may be able to give the code to somebody and say, hey, test my application. So, but then keep that in mind. So what is gray box testing? Gray box testing is a software testing method which is combination of both white box and black box. It's a technique to test the software product or application with partial knowledge of the internal workings of an application. So it's kind of like, you don't have all of the information, but you know some of the information. So how would, like, in an example, what kind would be this type of testing? Like, what would involve? So I was just thinking about it. Let's say I have a application built by Microsoft, and in their software release document, and they say that they are using some open source modules in it, and they'll kind of describe what they are, but they will not go much detail as to how they've used it. but they'll put out some information. For somebody who is testing this, they may use that as, oh, yeah, I know what they've used. I'm pretty sure they must have integrated it this way because all of that information is on the internet. It's an open source software. So that is kind of like gray box testing. So keep that in mind. And the other type of or other method of testing is dynamic testing. And then the opposite of it is static. So if you know, I've seen put a person running. So this basically means when the system or the software is being executed or being run and its behavior is observed. So you observe its inputs and outputs. This is the dynamic testing. How about static testing? So static testing is when you have a code, you observe the code, you know the code internal. That's why I have like zeros and ones there, and is observed without actually executing the system. So what is manual testing? All right, so the manual testing is if a human person sitting in front of a computer is actually testing the whole program. I mean, he's running scripts that he's typing. He's actually doing all the hard work. It's a more expensive kind of testing because you're paying somebody to do it. So cost is involved. Obviously, there's higher costs, but also it could be that a specialist who understands that software really well is testing it. So manual is when a human is actually testing the software. Automated, you guessed it, it's automatic. There are several testing applications that you can use. Basically download them, install it, and then you can point it to your program and it's going to run a few common tests. Now you can customize those tests. In most cases you can come up with your own playbook sort of and have some modules tested. Again, it's all automated. So no human is actually sitting in front of a screen and testing them. So that's the major difference. So we go into testing types. And so those were testing methods. These are testing types. Again, there are over 30, 40 types of testing. I have a link that I have put in the notes. If you click on that, you'll see all of those various types of testing defined. Very useful to know just for your information. But for CISSP exam, I would try to know these really well because they come time and time, they are asked in questions. So what is unit testing? So testing of an individual software component or a module. So remember, going back to our SDLC, we had a software requirements taken down and we have it all ready to go. And then we break those into different units and let the development team take it and run with it. But then when they're done with their code, building the software or building that unit, they need to test it. And this is basically what unit testing is. So they're individually responsible for testing those little units, and they have to report to their own team. And if they find something that's failed, they need to go back and fix it. So that's unit testing. Integration testing, as the word says, is testing of a completed software system. A quality assurance team tests for components if they're working together as outlined in the SRS or the design specifications. So this is more on the quality assurance where they are looking at the testing as a whole software, not just the little bitty units. So something to keep in mind. The unit testing requires detailed knowledge of the internal program and design and code. However, for the integration testing, again, it can be like a black box testing as well. Somebody have a question? All right, so we go into regression testing. Regression testing is a specialist. Okay, I keep using the word specialist, but regression is somebody who testing the software when there are changes made to the software, whether it's after deployment, you make a little bitty change, you apply a patch, but again, you need to test this software. You don't have to go through the unit testing, integration testing, but because you made a small change in the code, you should be able to do this regression testing. Anytime you make changes to the configuration of the software or the program or the code. Um, Again, exhaustive testing will be difficult. So most of the time, regression testing is done using the automated testing. So we had the manual testing and automated testing. So this will be mostly handled by the automated testing. So we are almost there, in a couple more left. Software penetration testing. Software penetration testing is also like a security testing. So software penetration testing is done to check how the software or application or website is secure from internal and external threats. This testing includes how much software is secure from the malicious program, viruses, and how secure and strong the authorization and authentication processes are. It also checks how software behaves for any hacker attack, malicious programs, and software data security after each attack. So, what happens to the integrity of the software after it is being attacked? Checks for all of that. So it's like a penetration testing. So keep that in mind. Very important for CISSP. It is also called a security testing. Acceptance testing. This is the part where the user accepts the software, right? So an acceptance test is performed by the client, the customer, and verifies whether the system meets the end user requirements as per the business requirements, and if it is as per the needs of the end user. Client accepts the software only when the features of the functionalities work as expected, and that's very obvious, right? So I've paid you to do something, and if you haven't delivered all of it, I'm not going to accept. So there's a lot of back and forth that goes on that may actually start some part of the SDLC, because it's still part of the SDLC, and until those requirements are met, this acceptance testing continues, this phase continues. And also, it is the last phase of the testing. So after which the software goes into production. This is also called sometimes as user acceptance testing, UAT. Question
So
time.
one quick question. So,
Sorry.
so regression testing is the last one or the UAT is the last one?
So regression testing is not the last one. It can keep happening. So after you deploy it, you may have a software change that can take place during the maintenance cycle of the software, and you may do a regression testing at that point. Acceptance testing happens in the SDLC lifecycle, where when a project needs to be completed, signed off, that's when the acceptance testing occurs. This is like the last part of your project closure document.
So
Okay.
regression testing is like comparing how after a change is made, how the application is working compared with how it previously worked, right?
Yes, does that necessarily initiate another software penetration testing or something else? So regression testing basically just tests, the extent of changes, but also tests the different modules. However, not very exhaustive, because it is usually done using automated systems most of the time. Kind of a good example would be like if you were a vendor for some sort of a control system software, and they were putting out trying to patch a vulnerability, and so they make a little bit of change in the software to fix that vulnerability. However, in order to prove that it is fixed, you'll obviously do a software penetration testing at that point. But then to see how much code has changed, you will also do a regression testing, which will probably initiate other testings necessary. So it's kind of like the first step that you do after your code has changed.
So regression test is basically it's an affirmation whether you've introducing functionality, whether functionality behavior is expected, and also comparing that that test to the previous test to see if any baseline deviation, because it could have a bad impact on the when you release the functionality, it could have a bad impact on your previous release. Is that part of
Yes,
the testing?
yes, it is. It is regression testing as well. So you are basically
Yeah.
comparing, you have a software that was released and it was all working fine, but then we had to make this change. Does that impact all of those requirements? So you're absolutely right. It definitely tells you whether the changes that you made to the code impacts any of the other tests that it had passed before, any of the requirements that it had met before.
So suppose if we have a working software,
Uh-huh.
like one that is being used now, and we find some vulnerability. So how is that fixed? Should we move, like, what the developers do at that stage? So
Hey, hi.
do they take
Can we
this?
consider the testing similar to the interface testing? No. My question is, the interface testing, is it different than the integration testing? So I refer one more term of interface testing for the integration testing.
So predominantly interface testing, as per me, refers to three, right? APIs, your user interface, and your hardware, physical hardware, right? Yes, because there are three terms, right? Into that the interface testing. One is that the API, another is that the user interface, right? Or the GUI, or that the CLI prompt.
Okay.
And third one is that the hardware.
All right, let's move on. Let's see. So this question here, in software testing, installation testing would test what?
Sounds good. I don't know.
Yeah, that is the
I'm
right
not-
answer. So
Ah,
installation testing is when you are taking a piece of software and basically running it on the customer's hardware. So the key word here is the customer's hardware, and you are actually, it's more like, before the user acceptance testing, you want to make sure you do the customer hardware. And sometimes it's also called as factory acceptance testing, where you send your hardware to the developer. I don't think it's very common in the software industry, because most of the time you can find similar hardware and then you can test them. But with, like, I'm from the industrial control systems background, and for us, if there is a company that developed a software for us to really make sure that it runs fine on our hardware, we actually ship the hardware to the company, and they do like a factory acceptance testing. It goes on for days before they actually finish it and fix any issues. So they'll probably, at that time, they also fix things because they have the hardware there and they can quickly test it and so on. So that's and then obviously it comes into the customer's location, and then they do a user acceptance testing as well after that. So, all right. So I have a bonus question in this particular one. So this is really the last part of my discussion today with software testing. Hope it gave anybody who was just starting out with CISSP, studying for CISSP, as well as for folks who are, already gone through this chapter, and hopefully that helps some clear some doubts, or if it let put some more doubts in your head, so at least now you can go back and read. But my main intention was to kind of cover the basics, the terms at least. So in software acceptance testing, what is the purpose of the user acceptance test, which is the UAT? So
To ensure the software is functional for and tested by the end user and the application
manager.
manager.
Okay, let's go through this. Let's go through this one by one. Okay, so to ensure that the backups are in place, um, doesn't even talk about software there. To ensure software is as secure or more secure than the rules, laws, and regulations of our industry. Doesn't make any sense, but okay. To ensure the software perform as expected in our live environment versus our development environment. It kind of sounds like it, but then let's read the last one, like everybody said. To ensure the software is functional for and tested by the end user and the application manager. I would say, the application manager is also like the asset owner or the application owner. So think about him as the senior management sometimes, or the owner. So I would say the answer for this one is D. Okay, so one more question before we get into our quiz. When we want users to test our software but want key features disabled, what do we release? Anybody? This is a good question. It can come into in your CISSP exam.
Well, I would have to guess this one, so it's not A. It's not D.
Display.
So it could be C or B. I'm just gonna go with C. This is a wild guess.
Okay. Anybody else?
I'll go
I think
with
it should be, it might be A, right? That's my guess.
So when I first saw this question long time ago, when I was first ever, understanding what type of software exists, I chose the C because I thought, hey, I want my software to be tested, and I don't want anybody to pay for it because I'm trying to test the software. So as a courtesy, I'll give them for free. However, the right answer in this case is crippleware. Excuse me, crippleware. And crippleware is basically, when you think about cripple, is when you crippled a functionality. So in this particular case, they have disabled the key feature, and crippleware is actually a real term. So
I don't remember running into the term cripple in the OSG.
yeah, me too. No, I don't remember seeing it either, but I saw this question. I want to say trying to remember where I got this question from, but I can look it up. I can send you where I got it from because they have some questions like this in that form. All right.